Hashing. The core foundation of decentralization, exploring how hashing powers secure, decentralized systems like Bitcoin and beyond. Welcome to the Satoshi Signal. Today we're diving into the fundamental role that hashing plays in decentralization. Hashing isn't just a buzzword, it's the backbone of technologies like blockchain and cryptocurrencies. We'll explore how it works, why it's secure, and how it's applied in real systems like Bitcoin. Hashing is a process where any input data, text, numbers, files, is transformed into a fixed-length string of characters, usually hexadecimal. For example, the word hello produces a totally different hash than hello, even though they look similar. This is one of the key strengths of hashing. It's highly sensitive to changes. Hash functions have several critical properties. Deterministic. Same input always gives the same output. Avalanche effect. A tiny change in input drastically changes the output. Fast to compute. Even large data can be hashed quickly. Collision resistant. It's nearly impossible to find two inputs with the same hash. These properties make hashing reliable for data integrity and verification. There are several hash algorithms, each suited for different purposes. SHA-256 is widely used in Bitcoin. SHA-3 is a more recent standard by NIST. MD5 was popular but is now considered insecure. Notice how the hash of block using SHA-256 results in a complex alphanumeric string, making it hard to reverse engineer. Hashing plays a central role in Bitcoin. Blocks are hashed to ensure data integrity. Proof of work involves miners finding a nonce such that the block hash meets certain difficulty criteria. This process ensures security and trust in the network without a central authority. Hashing is key to decentralization. It enables consensus by linking blocks securely. Tampering with even one transaction alters the hash, breaking the chain. This makes blockchains immutable and tamper-evident, ideal for decentralized applications. Think of hashes as digital fingerprints. Just like a fingerprint uniquely identifies a person, a hash uniquely identifies data. Verifying identity or content becomes quick and reliable. This analogy helps non-technical audiences grasp how hashes function in digital systems. Merkle trees are hierarchical structures of hashes. Pairs of transactions are hashed together to form a parent hash. This continues up to the root hash, which represents all underlying transactions. This enables efficient and secure verification without processing every transaction. Digital signatures rely on hashing. The data is hashed first. The hash is then signed using a private key. This ensures the data hasn't changed and confirms the sender's identity. It's foundational for secure digital communication. Hashing secures more than just blockchains. Passwords are stored as hashes, so even if a database is leaked, the actual passwords remain hidden. Files can be verified using their expected hash, ensuring they haven't been tampered with. These are practical, everyday uses of hashing for security. Example: using MD5 for file verification is risky because it's prone to collision. If you hash 1234 and ABCD and get the same output, it's a failed hash function. Always use secure hashes like SHA-256 or SHA-3. Post-quantum cryptography is being explored to ensure hashing remains secure even with quantum computers. Projects like decentralized IDs use hashing to represent your identity in a secure, verifiable way. In summary, hashing underpins trustless, decentralized systems. It ensures data integrity, enables secure consensus, forms the core of Web3, blockchains, and beyond. Without hashing, decentralization wouldn't be secure or scalable. Hashing is like the DNA of decentralized tech, unseen but critical. From mining to securing identity, it underpins trust and security in blockchain ecosystems. Let's explore any questions or real-life examples you've encountered about hashing, blockchain, or decentralization. Thank you for being part of this journey into the backbone of decentralization. Keep questioning and learning. Thank you for being part of this exciting conversation. New videos are updated quickly. Remember to subscribe this channel, comment, like and share. Check out the playlist for next videos. Help equip others to navigate in this new crypto world. Thank you.